Hi and welcome to this module on working in the shell and using redirection. What we'll do in this module is we'll have a look at what a shell actually is, what the functionality is, and why a shell is very important for system administration. We'll also have a look at what the different I/O streams are and how we can redirect those with regards to the shell. And by doing so, we'll also learn some Linux commands, which is always handy when you're working in the shell. If some terms are new to you, or if you do not know any of these commands yet, please don't worry, because we'll do it one by one, we'll do it step by step, and hopefully everything will fall into place as we go along. And Henry's here to help as well, by the way. So when a user logs in, he or she will usually end up in a shell. Now, what exactly is a shell? So let's go back to the introduction in which we saw that the hardware is managed by the kernel. But how does that work? I mean, who asks the kernel to do things? Well, this is where the shell comes in. The shell is used as an interface to the kernel. So the user or administrator can use tools to assign tasks to the kernel. So graphically, you could say that the tools like copy, remove, and list can be used to ask the kernel to perform certain tasks. The shell allows us to kind of instruct the kernel to work for us. Now let's take a closer look at the shell and the streams. As stated, when a user logs in, usually a shell gets started on his behalf and he will work in that shell. This means that the user always ends up in the shell that is for him or for her alone. Another user that logs into the same system will get their own personal shell. A user has a user ID that defines him, and this user ID is connected to the shell. So the system knows who is working in what particular shell. Now please pay attention because this is pretty important. Let's say we're logged in and we want to start working. We use the keyboard to type instructions. This keyboard is regarded as the standard input device, or std-in. So by default, the keyboard is the device that can be used to put the kernel to work. The second device that's connected to the shell is a terminal, to which it can send its output. This is regarded as the standard output device, or std-out. And finally, when something goes wrong and an error message has to be printed, this is done to the same terminal as where std-out is sent to. This is regarded as standard error, or std-err. In Linux, everything is a file. This means that devices are also files, like everything else is a file. Now, to describe the keyboard and the terminal devices, each shell gets the same file descriptors, as they're called. And these file descriptors will point to the devices. The file descriptor for standard in is 0, standard out is 1, and standard error is 2. So initially, these three file descriptors are available in any shell that you start. Now, what does that mean? This means that when you address 0, 1, or 2, you can redirect the input or output or error to a different file than the default file. So for example, if you want to redirect the standard output to another file than the terminal, you can do that using a 1 and then a greater than sign, which stands for redirect. Thing is that 1 is the default, so you can leave it out and simply use the greater than sign. And if you want to redirect standard input, you can use 0 and then the smaller than sign. But since file descriptor 0 is the default for input redirection, we can also leave it out and simply use the smaller than sign. And if we want to redirect the errors, we can use a 2 greater than sign and then the file name. Now let's have a look at some examples of both. With the ls command, we can list files. We can redirect the output like this. So we run ls greater than output file. The name of the output file is arbitrary, so you can give it any name you like. Now with the cat command, which is short for concatenate, you can read the contents of the text file that we just created. With the ps command, we can list our personal processes. And if we want to, we can save the output in a file, like ps greater than output file. Now please pay attention. If you redirect your output to a file that already exists, you will lose that content. So in fact, when you use output redirection, it will first create the file, if it does not exist yet. And if it does exist, it will empty the file. That's the first thing it does. This means that whatever was in there is gone. And in case you don't want to empty the file but simply append the text to the existing file, you can use double output redirection. With double output redirection, the file will be created if it doesn't exist yet, or if it does exist, the output will be appended. Again, let's create a file with the list of files. ls greater than output file. We'll empty the file and put some new text in it. To count the number of lines, we can use the word count command with the -l option. And we see that there is a particular number of lines in this file. And now we append, and we run the word count command once more and see that there's twice the number of lines that we initially had. Next to single and double output redirection, we also know error redirection. Remember, the file descriptor for errors is 2. So if we want to redirect errors, we use error redirection by prefixing the output with a 2. So we first generate an error by trying to list a file that doesn't exist, and we get an error message. Now, if we do not want to see the error, we can simply redirect it to a file like this. Or we can combine things. So we list the file name output and we list the file name no file. The output will be sent to the file output and the errors will be sent to the file errors. Or if you want all of the output to go to the same file, you can use the ampersand like this. ls output file no file greater than out 2 greater than ampersand1. This means that the output of the errors will be sent to the same file as where we send file descriptor 1 output to. You can also send your output into a black hole kind of thing, which is the device called /dev/null. Whatever you send there will be lost forever, so you will simply get rid of the output. And finally, there is input redirection and double input redirection. We won't discuss double input redirection here, but keep it for a later module. Single input redirection is used to get your input from a different file than from the keyboard. So we don't use the keyboard, but we use a file to get our input. This can very nicely be demonstrated using the mail command. I can send mail to a user in my system, so if I want to send a mail to myself, I can run mail linuser. It'll ask for a subject and then I type the message. The way to finish this program and actually send the mail is by typing Ctrl-D. Now, instead of typing a message, I can also use a prepared file by using input redirection. So I first create a text file with any name. Then I will send the mail using input redirection. So I run mail linuser smaller than sign mail text. Now to view my mail, I open the mailbox and I see that I have 2 new mails. Now to summarize, we saw that a shell uses file descriptors to address input and output devices. Redirection is accomplished by using greater than signs and smaller than signs. We discussed output redirection, error redirection, double output redirection, and input redirection. Commands we used were ls, ps, word count, cat, and mail. Now if you like, you can pause the video and have a look at the following commands that we used in this module. So please open up a terminal and try these commands for yourself.